All right, so this chapter we're looking at chemical equations. Chemical equations have the basic formula of reactants on the left, then we have an arrow, and then the products are on the right. The arrow is referred to as a yield sign. So we can have word equations and symbol equations. So a word equation might look like silver plus sulfur yields silver sulfide. Another example would be like methane plus oxygen yields carbon dioxide and water. In the word equations, we don't see any quantities. Just their words, no quantities or formulas, I guess. So most chemical equations really aren't written in words. They're written with the symbols and the formulas. Chemical equations represent a chemical reaction that displays the reactants and the products with chemical formulas. Your skeleton equation is an equation that shows only the formula of the reactants and products with nothing to indicate relative amounts. This is seldom used. Seldomly used or seldom used? One or the other. Doesn't really matter. These are important symbols that you could come across in chemical equations. The plus sign is used to separate multiple reactants or products, and it's better to think of the plus sign as the word and versus actual plus, because sometimes addition is not happening. The yield sign separates the reactants from the products. This will become important in a couple chapters. This double arrow replaces the yield sign. This is because this is for what we call a reversible reaction. More important for this particular chapter are these four symbols right here. Those four symbols will just be written as subscripts by either an element or a compound, and it indicates the state of matter that it is in. And so that becomes important in some chemical reactions. You might come across these in this chapter. The yield sign with the PT. This is written above the arrow is used as a catalyst for a reaction. A catalyst is a helping hand, so to speak. It usually speeds up the reaction. Or it's another compound that will not affect the reactants or the product. It just affects how the reaction happens. The delta over the yield sign indicates that there is a need for heat in order for the reaction to happen. Balancing chemical equations, a chemical equation in which the mass is conserved and there are equal numbers of atoms of each element on both sides of the equation. We balance chemical equations with the use of coefficients. So the process here is to add coefficients to elements as necessary. So some people like to make charts of the elements involved, elements or compounds involved. Some people can just see it, but the point is the number of elements of a particular kind, so the number of carbons on the reactant side must equal the number of carbons on the product side. So in this case, do we have equal numbers of carbons? Mm-hmm. Yes, there's one on each side. So then we look at the hydrogens on the reactant side. How many hydrogens do we have? Two. And on the product side, we have 4. They are not the same. So when it comes to balancing equations, we cannot take away atoms. We can only add them. And we do so by placing the coefficient out front. So which hydrogen, the reactant hydrogen or the product hydrogen, do we need to manipulate? The lower number or the higher number? The lower number. So that would be the reactant hydrogen. And what number do we need to place out front in order to balance it with this 4? 2. We do that because this subscript 2 gets multiplied with the coefficient 2 for a grand total of, now we have 4 hydrogen atoms on the reactant side. And how many do we have on the product side? 4. So now our balanced equation will look like this. We have the same number of carbon atoms and the same number of... Where did the 2 go? Which 2? Right here? I don't understand your question. All right then. All right, so another thing that you're going to be needing to do is taking a word equation and transferring it into symbols, or going vice versa, symbols into words. So we'll just practice this with this particular example. It says aqueous solutions of lead 2 nitrate and sodium chloride are mixed. The products of the reaction are an aqueous solution of sodium nitrate and a solid precipitate of lead 2 chloride. So at this point, I think I want you to give this a whirl on your own, get something written down, and then we'll look at it as a class. All right, so the first thing we need to do is we need to write the formula for lead 2 nitrate. So what did we come up for that? Lead. PB. Okay, good, solid. Actually, nitrate is NO4. NO3. What's the charge on nitrate? Just negative how many? 1. And what's lead's charge? 2. Plus 2. So how many nitrates do we need? 2. And it tells us that it's aqueous, so we need to indicate that in our equation. So in parentheses behind it, you write the symbol for aqueous, which is AQ. And sodium chloride are mixed. Sodium is Na. What's the charge on sodium? +1. Chlorine is -1, so we're balanced there. And aqueous solutions, so they're both aqueous. And then we get products are an aqueous solution of sodium nitrate. So that would be Na, which is +1, NO3, which is -1. So sodium nitrate balances already, and it's aqueous, so we mentioned that here. And a solid precipitate of lead with a +2 charge, and chlorine, which has a negative. So how many chlorines do we need to balance that out? 2, very good. And it is solid. Now the last part here is we need to make sure everything is balanced. So looking at lead, there's how many on each side? There's 1 there. And how many on the reactants or product side? 1, very good. And then how many NO3s? We have 2 here. And how many NO3s do we have here? 1. So how are we going to fix that? Add a 2, good, right here. Okay. Now looking at sodiums, how many sodiums on the reactant side? Pardon? 1. And how many over here? 2. Good, because this orange 2 goes to both the sodium and the nitrate. So how do we fix that? Good, we put a 2 out here. So then the last element to look at is chlorine. How many on the reactant side? 2. And the product side? 2. So do we have everything balanced out? Yes. Very good. So your final answer would be PbNO3 2 aqueous plus 2 NaCl aqueous yields 2 NaNO3 aqueous plus lead Cl2 solid. Kenzie?
So on the reactant side, you want like the two elements that are like in front of everything. You have to switch around. Things in front of NO3 and PV.
Yeah, you don't need to figure that out for tonight, though. That's not part of your assignment. You'll be given the full equation.
Okay.
So we just balance it pretty much.
Write them and balance them, yep. Okay. So just remember